Welcome students. In this video, we will be doing implementation of circular linked list. Okay, fine. We'll start. Already in the previous videos, we have discussed like what is circular linked list and if a circular linked list is taken, how to display all the nodes of a circular linked list, both iterative as well as the recursive approach of the same methodology we have discussed. So now in this video, both the recursive as well as the iterative approach will be implemented and it will be checked whether it is working perfectly, right? Fine. So now we will just start with by taking editor, like, so first of all we want a function called as create to create a circular linked list, but it's not going to be the usual create method that create function that we have taken. Okay, so there is some change that we are going to do with the existing create function that we have. So let me copy the set of code and include stdio.h, then it is integer return type a main function. Before integer main, I'm going to take this create function. Okay, so this create function actually wants a help of include stdlib.h, and also it require struct node, and the data member is going to be integer data, and the next member is going to be the self-referencing one struct node star next, and a semicolon to end it. Okay, fine. Now this create function is a normal, it's a function which is going to create a linear linked list, which will be having null at the last of next, which is a linear one. To make it a circular, what I wanted to do, I want to connect the last node again with the first node, which means last of next should not be null, it should be equal, it should be holding the address of the first node again. That's how it becomes circular. So only one line I'm going to add here to make it a circular linked list. After inserting all the nodes coming out of this while loop, I should check last of next. And last of next will be equal to, last of next is equal to, I should connect it again to the first node. So what is the address of first node? It is in the pointer called as first. So last of next equal to first, which means last node is again connected to first node. And after that we are just returning first, the address of one node of the circular linked list, because as we discussed earlier, okay, there is nothing called as first node, there is nothing called as last node. So now circular linked lists have been successfully created. The same method, same function, but extra one line we added, that it is last of next equal to first after completing all the steps. So it becomes circular now. Now in the main function, let me create a pointer, structure pointer called as first, and let me call the function create. Create function will be creating a circular linked list, and address of one node of the circular linked list will be written back, which will be captured by the pointer first. Now this pointer first in main function is holding the address of one node of the circular linked list. So if we have at least at the address of one node of a circular linked list, it is enough so that we can visit all the other nodes easily, because it is circular. Okay, now we will write the iterative display function. Okay, so it is return type void, function is actually display is the Name of the function. Then what is the argument that it requires? Display function of, like display CLL, because it is circular linked list display. What it requires? It requires the address of first node. Okay, it requires two arguments. One is both are going to receive the address of first node, but one we will change, the other one we will not change. Okay, so we will have the argument as struct node star first. One argument we will take the address of first node. Inside the function, we will declare a pointer called as temp, and for to which we will give the address of the first node also. Now we will use temp to traverse, but first will remind, we will not change first. Temp will be used for traversing the linked list. Now for traversing, what we usually do, we will be moving the pointer temp from one node to next node with the help of a syntax temp equal to temp of next. So temp equal to temp of next is a statement or syntax that we use for a pointer to move from one node to next node. Okay, fine. So until when you will be doing this temp equal to temp of next process is a question. Not only one time, because you're going to traverse all the elements of linked list. So this is not going to be done for one time. So let me write it inside a loop to repeat this step again and again. So temp equal to temp of next will be repeated again and again, but until when? Already we have discussed this in the concept explanation also. Again temp should not come to first node. Again temp should not reach the address first. So I will say that temp should not become equal again to first. Okay, so while temp not equal to first, we can be executing temp equal to temp of next. But we were seeing this that discussing about initially temp and first are equal, then so checking this condition initially and then proceeding will not going to work fine, because initially temp and first is equal. So before proceeding, if you check temp not equal to first, definitely it will not even enter inside the body part, at least for one time. So that's the reason what we did is we took this while and we converted it into do while, because we proceed first of all and then we go for condition checking. We proceed with certain step and then we go for checking. Okay, and before moving the pointer from one node to the next node, I should first of all print it. That's a job, right? So printf percentage d space comma temp of data. So first of all I will print the data and then I will move to next node. After that I will be checking whether temp and first pointer are equal or not. If it's not equal, we continue. If we again at some point of time again temp and first is meeting, then it's the end. We have gone through one cycle and we just printed all the elements of the circular linked list exactly for one time. We're not going to repeat any element again. Okay, fine. So we will check. Now we will check. We know that the create function is actually connecting the entire linked list circular. Now after this in main function, let me call display CLL function and let us pass the address of the first node. That's it. Now we will go for execution and check. gcc-o hello, it is display CLL dot c. So is there any syntax error? Yes, no syntax error. We'll go for execution. So waiting for us to enter elements. So like going to be 12. Okay, it's going to be 12. 1 minute. It's going to be 12, 23, 34, 45, 56, 67 and -1. So we will check whether the same elements are getting repeated again, getting displayed again. Yes, even though if it is circular, even if 64 is again connected to 12, but we are just breaking it while we are printing. While we are printing, what we were doing, we were just checking whether temp and first is equal. So again, when we are traversing using temp pointer, again if the temp pointer reaches to the first node, again we stop the process and we stop the printing process. Okay. So the iterative approach of displaying all the elements of circular linked list is perfectly working. Let us now go with the recursive approach of the same. So it is void and recursive display CLL, circular linked list, and what are all the arguments that it is going to take? Okay, so it is going to take two arguments. So we'll just look at the code that we already discussed. It is going to take two arguments. One is head, the other one is temp. Okay, so one will be holding that, both will be holding the address of the first node, but head will not be changed, but temp will be changing, because temp we will be used for traversing as we did in the iterative approach. Okay, fine. So inside we want a static variable called as flag that we should remember. Okay, fine. So now the two arguments are going to be struct node star. Head is one argument, then the next one is struct node star temp is the next argument. Temp is used for traversal, head is used to like fixedly point to the first node, because when I am traversing using temp, at some point of time, in order to find whether I'm reaching the same head node again, I want the address of it. Okay, so to store the address of the first node, I'm having this head. It will not be changed at any cost. Now inside the function, first thing that I require is a static variable, integer variable called as flag, initialized to 0 by default. And what is going to be the condition? The condition, what we know is the same condition whatever we are giving here, temp not equal to first. But as we know, initially temp and first are equal, temp and head are equal. We should first of all proceed. Only for the first time we need to proceed, and then we go for checking the condition. So for that, doing that, if we check whether flag is equal to 0 to verify whether it is the first time you enter, first time you are going to do the process. So if flag is equal to 0 or otherwise temp not equal to head, if any one of this condition is actually true, if any one of this condition is true, then these steps will be taken care. So first thing is I will be changing the value of flag to 1, because only for the first time this condition should go, and after I change flag 1, then this condition will not be true. Only temp not equal to head will be checked. Okay, now what's the first thing? We have to print temp of data. So I will do printf %d comma temp of data. Yes, after that we will be recursively calling the same function or display CLL, and instead of head we will pass the same value, because head we will not change. But temp, what we have to do, temp we have to change it to temp of next, because we want to make a traversal, right? So first we entered with the temp, next we have to go for temp of next, next time when we enter we have to go for temp of next. So traversal. Okay, traversal. Yes. So if flag equal to 0 or temp not equal to head, you change flag to 1, print temp of data, and recursively call the same function with head the same, but temp of next you have to pass instead of temp. Okay, fine. Now instead of calling this iterative approach, let us call the recursive approach display function and check. Let us save the file and now we will go for compilation and execution. So compilation, there is an error. See, okay, here, see, while we are calling, we're passing only one argument. Here declaring two arguments are there. So we have to be passing the address of first node twice. One for head, the other one is for temp. Now we will go for compilation. No error at all. Go for execution. So I will enter, for example, 34, 12, 78, 98, 1, 5, 4 and -1. So the same elements are getting printed again. Okay, see, you can just check the same elements. Okay, 34, 12, 78, 98, 154. So the recursive approach is also perfectly working. So iterative approach of displaying all the elements of a circular linked list, and the recursive procedure of displaying all the nodes in a circular linked list, both are perfectly implemented and also it is working. Okay, fine. Thank you, students.